Hi guys, welcome to part 2 of this one-dimensional wave equations. Here we are going to see how to find the solution for a string which is bisected and it is considered as a wave equation. So now let us go to the problem part, and most of the steps are very similar to our part 1 except that f of x value, that is we have to find f of x in this problem. It is given a string of length 2L is fastened at both ends. Okay, so it is given the length of the string is 2L and two ends are fixed. The midpoint of the string is displaced transversely through a small distance b, and the string is released from rest in that position. See, if released from rest in that position means the meaning is it is having a zero initial velocity, and we have to find the initial displacement, namely y of x comma 0. Find an expression for the transverse displacement of the string at any time during the subsequent motion. So let us have the one-dimensional wave equation, which is given by dou squared y by dou t squared equal to a squared into dou squared y by dou x squared, where a squared is nothing but t by m, which is the tension by mass. See, now the correct solution is given by y of x comma t equal to a cos px plus b sin px into c cos pat plus d sin pat. See, now we have to write the boundary conditions for this problem in order to find the values of these arbitrary constants. So let us take 2L as some capital L. This is for our convenience. See, it is given the two ends of the string are held fixed. Okay, at x is equal to 0 it is fixed, and at x is equal to L, here capital L is nothing but 2 into small l. See, it is in the mid. Okay, the midpoint of the string is displaced transversely. Okay, transverse means it's some perpendicular movement. Okay, and it is at a distance b. Okay, and it is given in the problem displaced transversely through a small distance. So it is in the midpoint. So if it is of length capital L means the midpoint of it is nothing but L by 2, and the y length is nothing but b here. So this point is taken as L by 2 comma b. Okay, now let us come to the boundary conditions one by one. It is given the two ends are fixed. So y of 0 comma 2 equal to 0. Sorry, y of 0 comma t equal to 0. Second one is y of L comma t equal to 0, because here L is 2L. For both of these conditions, t value should be greater than 0. The third condition is the initial velocity is 0. The third condition is initial velocity is 0, and the fourth one is nothing but initial displacement. That is what we have to find. Okay, so this f of x is nothing but the equation of the line joining the 2 points OA and AB. So for that we must know what is the equation of the line joining the 2 points x1 y1 and x2 y2. You know that x minus x1 divided by x2 minus x1 equal to y minus y1 divided by y2 minus y1. See, now our f of x comprises two terms, that is OA, the equation of OA, and the equation of AB. Now let us find the equation of OA. So OA is nothing but the line joining the point 0, 0 and L by 2 comma b. So in this formula we have to take x1 y1 as 0, 0 and x2 y2 as L by 2 comma b. So let us substitute those values. So you will get x minus 0 divided by L by 2 minus 0 equal to y minus 0 divided by b minus 0. So when we simplify this, we will get this on cross multiplying and separating the terms. We will get y equal to 2bx by L, and this is valid for the x value from 0 to L by 2. So x varies from 0 to L by 2. Now we have to find the equation of AB. AB is nothing but the equation of the line joining the points L by 2 comma b and that is L comma 0. So now in the same formula, we have to substitute x1, y1 as L by 2 comma b and x2, y2 as L comma 0, right? So in this, after substituting and simplifying the terms and by cross multiplying, we group our y value as see, we are cross multiplying it and then we are simplifying, taking y terms to that one side and rest of the terms to the right hand side, and we will get our y value as 2b by capital L into L minus x. It's a simple calculation which we know in our early schooling, how to find the equation of a straight line joining the 2 points, and this is from the limit L by 2 to L. Okay, so now we have got our f of x as 2bx by L over the limit 0 to L by 2 and 2b by L into L minus x over the interval L by 2 to L. So now let us go to our problem part. Our problem in the first equation, that is in the most correct solution, we are substituting the first boundary condition. The first boundary condition is y of 0 comma t equal to 0. So if you substitute x is equal to 0, it is a cos 0 plus b sin 0 into c cos pat plus d sin pat. We know the sin 0 value is 0 and cos 0 value is 1. Y of 0 comma t equal to 0 because of the boundary condition 1. So we have c into cos pat plus d sin pat. Here c into cos pat plus d sin pat cannot be 0 because our t value is greater than 0. Therefore, the only possibility is a equal to 0. If we substitute a equal to 0 in our equation 1, we get y of x comma t equal to b into sin px into c cos pat plus d sin pat. Now, let us apply the second boundary condition in our equation number 2. So that is y of L comma t equal to 0. Now y of L comma t means it is b into sin PL into c cos PAT plus d sin PAT. Okay. So in this, x is replaced by L. Now when x is replaced by L, the condition says it is equal to 0. So now y of L comma t equal to 0, it is b into sin PL into c cos PAT plus d sin PAT. So in the first condition itself, we said this is not equal to 0. And here if you take these two or any of these two should be equal to 0. See, if I take b as 0, then the solution, and if I assume b as 0, then this will become 0. Therefore, what is the possibility? Our sin PL should be equal to 0. This is what I have discussed. So b cannot be 0. The c cos PAT into d sin plus d sin PAT cannot be 0. So the only option is sin PL should be 0. Sin PL equal to sin n pi and PL equal to n pi. That implies P equal to n pi by L. Now we have to substitute P equal to n pi by L in our equation 2. Therefore, we will get y of x comma t equal to b into sin n pi x by L into c cos n pi at by L plus d sin n pi at by L, because we know that our P is nothing but n pi by L. Okay, so that is substituted in that equation 2. Now before applying the third condition, we need to differentiate this because our initial velocity is given as 0. Initial velocity means dou y by dou t of x comma 0 equal to 0. Now we have to differentiate this equation with respect to t. Therefore, x terms are treated as constants. So now dou y by dou t of x comma t equal to b sin n phi x by L into differentiation of this is minus sin n pi at by L into n pi a by L plus d into cos n pi at by L into n pi a by L. See, now in this we have to substitute the third condition, dou y by dou t of x comma 0 equal to 0. That is, you have to apply t as 0. So when we apply t as 0, sin t, that is sin 0 is 0 and cos 0 value is 1 here, right? And here in this place we have to substitute 0. Therefore 0 equal to P into sin n pi x by L into d into cos 0 value is 1. We have it as n pi a by L. See here, we have to decide which term is giving the value as 0. Now b cannot be 0, already it is finalized, nothing is said about x, so this term cannot be equal to 0. N is a constant, pi is a constant, a is a constant, and L is nothing but the length of the string, and therefore the only option here is d equal to 0. So now we have to substitute d equal to 0 in the equation 3. Therefore we get y of x comma t equal to b into sin n pi x by L into c cos n pi a t by L. Now by multiplying this b and c, it is bc, and we are retaining the remaining terms as such, and this is taken as a single constant, say b1 into sin n pi x by L into cos n pi a t by L. By the superposition principle, we write the most general solution as y of x comma t equal to summation n equal to 1 to infinity bn sin n pi x by L into cos n pi a t by L. Okay. So now we have to apply the last condition. The last condition is y of x comma 0 equal to f of x. F of x is nothing but what we have found using the equation of the line joining the 2 points formula, and this is summation n equal to 1 to infinity bn sin n pi x by L into cos 0. Cos 0 value is 1, so we get f of x is equal to summation n equal to 1 to infinity bn sin n pi x by L. See, now this resembles a half range sine series in the interval 0 comma capital L. Now we have to find our bn. So bn is nothing but 2 by L integration over 0 to L f of x into sin n pi x by L into dx. Now we know f of x is defined in two ways like this. It is equal to 2bx by L in the interval 0 comma L by 2 and equal to 2b by L into L minus x in the interval L by 2 to L. So now we are going to split 0 to L as 0 to L by 2 and L by 2 to L. In 0 to L by 2, f of x is 2bx by L. So 2bx by L into sin n pi x by L into dx. And in the interval L by 2 to L, it is 2b by L into L minus x into sin n pi x by L into dx. Now we are going to apply the Bernoulli's formula. Now both the terms are having 2b by L as constant. So let us take that outside. So it is 0 to L by 2 x into sin n pi x by L into dx. Here it is L minus x into sin n pi x by L into dx. Okay. So now when we apply the Bernoulli's formula, this is u and this is our VDU. So let us VDX. So that is the Bernoulli's formula says uv1 minus u dash v2 plus u double dash v3 and so on. So this is u and this is our dv. So integration of this is nothing but v1. So when we do so, it is x, that is u, integration of sin n pi x by L is minus cos n pi x by L divided by n pi by L minus differentiation of x is 1, integration of this is minus sin n pi x by L divided by n pi by L. Already you have a n pi by L. So this will give us n squared pi squared by L squared. And coming to the second term, this is u, so L minus x, integration of this is minus cos n pi x by L divided by n pi by L. So this is u v1 minus u dash is nothing but the differentiation of this one. So differentiation of L is 0, differentiation of minus x is minus 1, and again we have to integrate this particular term. Already you have a minus, so minus of cos n pi x by L's integration is minus sin n pi x by L, and along with this n pi by L we have a n squared pi squared by L squared. Now we have to apply the different limits. Okay, see now the constant along with this cos n pi x by L in the denominator and the sin n pi x by L's denominator is taken to the numerator. Here also we have done like this. Now one by one we will apply the limits. Now it is 4b by L squared. Now x is taking the value as L by 2. So it is L by 2 into cos n pi L by 2. L and L will get cancelled. We will get this as cos n pi by 2 plus L squared n squared pi squared into sin of n pi x. In the place of x we have to substitute capital L by 2. So L by 2 divided by L will be there. So L will get cancelled. So this will become sin n pi by 2. Our lower limit is 0. When you substitute x as 0, 0 into anything is 0. Here sin 0 is 0. So we won't have the lower limit. And coming to the second term, our upper limit is L. So when we substitute x is equal to L, here L minus L will give us 0. And when we substitute x is equal to L in this place, L and L will get cancelled and sin n pi value is 0. Therefore, the upper limit for the second term is 0. So we will have only the lower limit that is minus of minus L by n pi, L minus L by 2. So L minus L by 2 is nothing but L by 2 into cos of n pi L by 2 by L. So L and L will get cancelled. You will get cos n pi by 2 minus L squared n squared pi squared into sin n pi L by 2. So L get cancelled. I will get a sin n pi by 2. See here there are two minuses, so it will be plus now, and here it is minus. So we will have a capital L square divided by n pi into 2 into cos n pi by 2 with a negative sign here and with a positive sign here. So these two terms will get cancelled. This minus into minus will be plus. So we will get 2 times L square divided by n squared pi squared into sin n pi by 2, because here we have one term and this minus with this minus will be plus. So we will get a 2 L squared n squared pi squared into sin n pi by 2. So inside the bracket, outside the bracket we have a 4b by L squared. Okay, so this is what I have explained. This is minus and this is plus, and you have 2 times this value. And when we multiply with this outside term 4b by L squared and L squared will get cancelled. Since you have 2 times this value, you will get it as 8b divided by n squared pi squared into sin n pi by 2. Therefore, by substituting the bn value in the most general solution, we get y of x comma t equal to summation n equal to 1 to infinity 8b into n squared pi squared into sin n pi by 2 sin n pi x by L into cos n pi at by L. Remember, here capital L is nothing but equal to small l. Therefore, we get this as 8b divided by pi squared summation n equal to 1 to infinity 1 by n squared sin n pi by 2 into sin of n pi here n pi x by what is L here? It is 2L cos n pi at by 2L, and this is the required displacement for S. So with this we complete this.